Okay. Okay, today we're discussing like data sets. Open source data sets, data from open sources. And PyPSA team have prepared some input data for PyPSA model. I had a look also and trying to connect right now with NetCDF and the switch. But today we're going to discuss what kind of data is it. And so Max will start and I will continue a little bit at the end with mirror data and like initial steps of connection with NetCDF and the switch. So actually, that's it. Max, are you ready? Okay, floor is yours.
Yeah, perfect. Thanks, Oleg. So basically, we have a little session planned on what data we are using at the moment. Okay, actually, Tom. Hi, Oleg.
Hello, Tom.
Yeah. So for everyone who's not knowing Tom, like he created a while back ago PyPSA, and I'm just currently in Berlin. Okay. Yeah, back to the training content. So we prepared, as Oleg mentioned, data for your countries, and that's really data that is by default available, and you can reproduce it anytime. And it's also kind of flexible, so you can produce it in many different ways and can check it. And I just share now my screen. Hopefully it works. No, Oleg, you need to give me some rights to share the screen.
Okay, just a second.
Yeah.
Okay.
And I think some of you also had a question like, okay, why, or like, what is this data? What is it being used for in general? Like the data I will show you in a moment. The basic idea is that we have in PyPSA-Earth the data ready, and we can generate for, it's like a model generator. We can create for any country in the world data. And we tested that for your countries. And then actually Oleg and Matthias, they're building interfaces to that. So you can basically easily read the model of choice, the data in, and then you can run the optimization for your planning study. And that's the kind of context on, like why do we show, the data from the PyPSA-Earth framework.
Max, you try to share your screen. Yeah.
Okay. Can you see Google now?
Yes, absolutely.
Okay. So basically what you have is, I think, this data folder. So for each of the countries, like these are 2-letter codes, we provide the data kits. There's a little readme, so written in Markdown. It explains basically what's the content here in this data folders. And yeah, we have current network data with power lines, transformers, converters, and so on. We have the country shapes, administrative zones, and kind of bus region that we create. And bus region is just a arbitrary created region in your country, covering an area close to your substation. Then we have the raw data from OpenStreetMap, so you can really investigate what was really the initial data that we used here. We have renewable profiles, hourly profiles for wind and solar. Then there's an iterative, and that's practically the areas we exclude because they're protected, protected areas and that kind of stuff. Because we disregard it from the expansion potential. Then there are cutouts, which are weather data, like they hold factors like humidity, temperature, wind and solar profiles, like wind speed profiles and solar radiations. And then we have some pre-solved data kits that are already partially then clustered. And maybe I should also show you a little bit. We have also the PyPSA-Earth paper. So whatever I'm talking here about, you can also reread that in the paper we shared recently. So just to give you a little bit of context, this is raw data. Oops. Looks like a bit of a mess. This is clustered. When I speak about clustered nodes, it's aggregating some of the raw data to have representative lines. These green lines, they're artificially created. So we have algorithms to mesh the network. Just to give you some vocabulary here, these are administrative zones. We're looking now at Nigeria at the moment. So this is the regions we're talking often about. This is the administrative zones. This is created from the network structure. So in the middle of each of these shapes is a substation, which transforms your voltage from one level to another level, and it's usually where the load is taken from them. And that is created on the raw OpenStreetMap data with all the substations, and then it's expanding as kind of k-means Voronoi cell creations. And it's the other kind of shape, like we have both available. So, and in each of the shapes, I think we covered it soon. Like this is the demand profiles availability that we have at the moment. That might be interesting for you. So when we speak about cutout, I was talking about cutout just a moment before. The cutout is, like a cell of choice. We can pick that, and then the tool that we implement in PyPSA-Earth, it creates a cutout, and there are little, we call it raster here from a terminology, because it's like a mesh network here, and each of this raster points, there's actually one point. You can imagine each cell has one point and there's information included, and each point contains, for example, wind speed. Here hourly profiles of wind speed, here the mean direct influx in this case, also an hourly resolution. We have as mentioned, this kind of Natura raster, where we define then for each data point how much I'm allowed to build. And then we have, basically we are saying then, okay, a PV plant can build so much, or like a photovoltaic plant needs so much space, and then we can practically define what's the solar photovoltaic requirements or potentials. And then we can, that information that was in raster form, like perfectly squared, we can put that data into any other arbitrary shape. And that's how we create the solar profiles. Okay, here's maybe nice to see what kind of clustering is possible in general. Like you don't see here, like all of these classes here, they're aggregated either to 4 nodes here, to 14 nodes, here 14 nodes, or 54 nodes, which you see here on the right. And there are different ways, like basically, I mean, that's a little bit detailed, but you can say, I want all the network detail, which is the red line. Yeah. So I want all the network detail included. Or you can say, I'm fine with, 4 nodes as network, but I want to cover every generation side in a high detail. So that's what you can distinguish a bit. That's some kind of data validation we did for in terms of Africa. Yeah, but anyways, you can use definitely this paper to read more about the data that is available and then how we validate that. Maybe you can use it for your country as well, some of the approaches to validate your data, and definitely report us on the quality. That would be super helpful. So as a next step, I just want to show, like, we go through one example now. We pick Bangladesh, and basically all the data is really here available. So whatever I mentioned here, bus regions, that's familiar to you now. I was speaking about that, renewable profiles, and so on. Power plant CSVs. So we have here in Bangladesh all the power plants for different retrofit years, dates when they were built, when they're planned to be deconstructed, with geolocation, and so on. I mean, there's really all the data inside.
At least you give some time to each other, and then you decide for a big thing. ठीक है ना? उसके बारे में चला क्या point of view है भाई, और मुझे काम क्या कैसे इसके.
Okay, we have someone speaking.
Is it probably a question?
Like, was there a question? Or does someone have a question so far?
So Max, what type of shape you are using? So please show the shape files for any region in the Bangladesh. Okay.
Okay. Like we will show that definitely in a. Like I can show that. So
now I want to just see the raw format data. What exactly for a particular country, what exactly data are you are using in formats? Okay.
So
okay.
it's GeoJSON. For everyone who's not familiar with GeoJSON, it's not sure if I can open it. It looks really ugly in a text editor. Let's see. Yeah, like it's not super human readable.
No.
But you can use then, like I will show you in a moment how you could use VS Code and then plot it, and then it's beautiful.
I have a small question. So when you show the data on Bangladesh for the different power plants, so those are existing power plants, and doesn't matter from what kind of sources they are now, right? Those are actual data.
Exactly, it's actual data.
Okay. Okay, this is one. And the other one is when you said initially you have the different administrative boundaries and you have assumed one substation in each of these. So that is also by assumption. You are just assuming that suppose there is one substation and then you are looking into, no?
We have the data. We have the data on the substation
Okay.
as well. So we have
Okay.
the raw infrastructure data. I mean, fingers crossed that everything is in good quality. In Africa, it was surprisingly good. But yeah, I think that will be also, you know, part of your feedback that we then have from this initial data kits in your training experience. And, you know, user experience, is this data good that we have in my, like in your country? If not, maybe we can even work together on, you know, improving that.
Okay, all right.
So Max, substation data you are collecting from the OpenStreet map.
Yep.
Okay.
The thing is, like you need to do some post-processing, you know, like first of all, OpenStreetMap extraction is difficult. And then you need to clean it, which can be difficult. And then often the OpenStreetMap data by itself is not useful at all. So you need to modify some stuff. And basically, all that consuming process of cleaning stuff and building the network, like we take care of that in PyPSA-Earth already. So you can, you know, figure out, like, I mean, you can always see the raw data. That's the cool thing. You know, from OpenStreetMap, you can see what we get out as a raw format. And then at the end, like we build these interfaces already on the cleaned. So like Oleg and Matthias, they build the interfaces on the already cleaned data. So, you know, you avoid doing all this complicated stuff again and again.
Sorry, Max.
Yeah.
But the idea of what you are talking about from Switch and NRJRT is that those models are going to use the same data, but just in different formats. That's the idea, right?
It's the same data. Like Switch in energy, like NRJRT, basically it's like a framework, and you just need to put in the data in the right, you know, spots, and then at the end, you know, because they're like math formulation, they should create the same result.
Is that the final data will be the same? So the idea is to create like an automatic script or something that translate the data between different formats. That's the idea, right?
The data will be the same. It will be just described in different languages, you know, like different frameworks.
Okay.
Switch describes it in its own way. PyPSA describes it in its own way, and NRJRT. So the data is the same, just the way you formulate a problem and describe the you know, energy system problem, optimization problem, just differently written. Yeah.
Perfect.
So,
Thanks.
so, like just you know, we're speaking different languages, English, German, and whatever, and we all have the same, you know, sometimes the same intention to say something, but we just use a different language, and that's how you can imagine that. The data is the same, you know, our intention or your thinking is the same, but the words are sometimes just different. Okay, I just want to show you quickly. So I opened in Bangladesh VS Code, Virtual Studio Code.
So Max, before starting the thing, so please once again, please tell me what extensions you are using right now to show all this thing in VS Code.
That's a good point, Suresh. So in VS Code, that's by the way, it's also an open source project from from Microsoft. And you can have here on the left side, you have extensions. And what I'm usually doing, if you install VS Code from scratch, you don't have anything. And what I'm just doing, you know, like I would look for GeoJSON because that's something I want to plot. And I have here at the moment GeoData Viewer installed already. And that's what you see here. Yeah.
So GeoData Viewer and GeoJSON, these two extension will required, right?
So GeoJSON is the data format, and GeoData Viewer is a tool, a plugin that can show it in that way at the moment. Right?
Okay.
But there might be also other tools, you know, like feel free to explore others. Like maybe, you know, I'm using old school stuff. Yeah. But like I like that quite a lot. It looks cool, and you can pick really any GeoJSON like that we have. Like, you know, all the 10 countries you can look into. Okay, what kind of shapefiles are provided? Let's explore some other things. What's the country shape? The country shape is now okay. The whole country is one. Africa shape. I think that's our. Yeah, like that's our bad. Like because, you know, we started from Africa building the model. Some of the naming is not correct, but what it does, it takes now the offshore shape and the land shape and merges them. And also look at the offshore shape only. Yeah. So what else do we have also? Yeah, cool. We have even more GeoJSON files. Let's plot. Let's check the raw lines. Bangladesh. Oh, cool. We have some lines here. So surprisingly a lot. We could check. I'm not sure. Like probably you can add here. Honestly, like I never did that. Probably you can just move. Let's see if it works. No, it didn't work. Okay. Yeah, but you can somehow add data. So I'm just. Okay, now I'm confused. So to get back. Yeah. Anyways, I think the point is clear. Like you can just, you know, explore your data a little bit here.
Max, is it actual data? So why the name is not changed? If it is downloaded from the actual server,
Yeah.
why it is Africa? We are basically seeing Bangladesh.
Good point. Sorry. Yeah, Suresh. This is just the way we coded that at the beginning. We could, yes, Suresh, mention here Bangladesh instead Africa. It is, I think, just statically coded, you know, like we said, like someone typed in, it's hard coded at the moment. You know, we wrote one time Africa instead of making it a dynamic function. But yeah, basically it shows really the country that you picked in the config. So here you see the config.
Yes.
You know, it's the option file.
Yeah.
And yeah, like, you know, I'm really sorry that some stuff is not, like we could really do that. We can automatically make that dynamic. But basically it will always take what is given in the config. And by the way, that's also interesting. So we deliver here the config. It's you know, the option file. If you attended to our tutorial, it's the option file. And you can use that config to exactly create everything from scratch for your country. And you can also modify certain things. So this is the config we were running. We used 2013 till 2014 as a weather year. And, you know, there are many more options. that you theoretically could adjust. Maybe it's not necessary, you know, but maybe just good to be aware of. If you want in your study, you find, okay, we want to investigate something in your modeling exercise. You want some other data. Have a look into the paper, I guess. That's a good start. And then definitely check here what options are available. And these are also documented. So these are, I probably think, not perfectly documented because we are working actively on that. But if I go here in configurations, yeah, I see here, okay. So this is the config, yeah. Scenario, clusters, and so on, and then you see, okay, what it means. I guess a kind of idea. Maybe it's not perfectly documented as well. All right.
I think
Anyways.
we have a question.
Yeah.
Varun, would you like to ask something?
Hi, thank you very much. Max, I have a question regarding the weather data which you are using it. You have shown like it's for the calendar year 2013 to 2014. So how,
Yes.
is it possible for us to use like the 2-year calendar data, like if we, for example, 1st April 2013 to 31st March 2014, like that? Is it possible, or we need to use like 760 data points only?
Like, you mean if we could change here, for example, the time to
for example, 2013 0401.
Yeah.
And end date is 2014.
It's possible. Yes.
31st,
you mean like
2014 31st, 03 31st.
03 31st, yeah, like this is possible.
This is possible?
It's like everything, yeah, like you can, I think there are like 50 years of data that you could retrieve.
Okay.
Yeah. But
thank you.
So like I just want to make you aware that this is like usually we use a single year. You could extract multiple years as well. I just want to make you aware that you might face some issues. You know, that something is not working from the beginning, but I'm 100% sure that we could make that relatively easily for multiple years. It's not a big change.
Okay. Yeah. Because sometimes it will be taking both the years when we are modeling it across optimization in the future. So that is why some features might not work. Thank you for this one. So I think it's all, Mike. Thanks a lot.
Awesome. Okay. Any other questions? Okay, if not, I think we are starting now with a little cool exercise, and then might be also interesting for Oleg. So, okay, I just want to show you, like, I'm here. You can see my terminal. Like could use that in VS Code as well, but I'm just using this terminal because it looks somehow more sexy for me. Okay, just cannot increase the size. So what I want to do now is I want to show you how I analyze the PyPSA network, and that might be also interesting for Oleg. Maybe he did it already to build an interface. But I'm currently in the DataKit demo I downloaded the data. So I picked that Google Drive. I picked that Google Drive stuff, and I downloaded Bangladesh here. So this is the local file. I had to unpack that, and now I'm in the Bangladesh folder, and you see, okay, config is there, network and resource data. Okay, the cutouts are not there. I have to download them as well. Didn't do that. What I want to do now is we have these networks here. Maybe I showed you that already, but these have a weird format. It's NC. What is NC? It's a NetCDF data format, and basically what it's like a collection of CSV files in a way, but just structured differently. Can also include some kind of metadata and that kind of stuff, and it's really quick as well. It's super fast and in general nice to access any kind of object, Python object or something like that. But I'm for sure R and like the R community uses that as well. I think the cutouts, they're also given a NC file. So this is also really in the geo landscape, geo analysis landscape used as well. So we're doing that mainly because it's one file, and it has all the PyPSA information inside as an object, and that it has all the data in a structured way in PyPSA, and then you can actually build an interface to other tools, other energy models, for example. And it's really one file and doesn't create a mess. But what we're doing now, we are open this file and we analyze what's in there. And then what we're also creating, we are creating all the CSVs. So I want to show you that this is also possible. Starting now, how would you analyze such a file? You open Jupyter Lab. I'm actually, sorry, just breaking it up. Just want to open PyPSA-Earth. Like sometimes you don't have Jupyter Lab on the base. So now it's opening Jupyter Lab. Okay, there's a Python free kernel. I try to import PyPSA. Funny. Cool, it worked. Okay, actually, I just wanted to show you that this sometimes fails. And when it fails, it means you don't have, like my kernel has somehow PyPSA inside, like the environment. But we, in the PyPSA-Earth GitHub repository, we write something about the kernel. Like sometimes you need to install a kernel, and I'm just doing that, shutting that down. Sometimes you have to install the kernel. Then I'm opening that one. So I'm opening that again, and now you have a PyPSA-Earth notebook with all the environments given there. So okay, so what we need to do now is to import somehow the network. So what I'm using here usually is OS. This is like operating system neutral. OS is like, if you don't know what's OS, I would just Google OS in Python. -s module. Okay, and this is like, it has something to do with path setting. Yeah. And I'm just using that to see, okay, where am I now? So my current path location is in that Bangladesh file, in the Bangladesh folder, and practically I want to go into networks, and I want to pick that name as well. So what I'm doing now is actually let's copy path. I mean, that's, you know, maybe the easy version. Yeah, let's do that. So this is the path. Let's see if I can import it already. PyPSA network. This is, by the way, something not I invented. You can just go to the PyPSA documentation. And I think then it describes somewhere how you can import networks. Here they're building some from scratch. That's also from scratch. Okay, let's see. Data import and export. You can really, that's really cool. It's well documented. You can import the network. Okay, it's not it's somewhere in the examples, like I don't find it now, like I would need to search a little bit. But basically it's super simple, that you just put the path of your file inside that object PyPSA.network, and then we have it already. I call that n, so I'm just assigning this object to n, and that's how I import a network. So if you attended the tutorial, PyPSA has these components, and you can basically analyze all the components energy system can have, like buses, I think generators were there as well somewhere. Generators, let's have a look into that. So when I add here generators, yeah, I see what data is inside here. Good. What I can do here as well, let's, you know, create quickly in plot. That's maybe what you always want to do when you analyze some of the data. So I want to analyze now, aggregate, you know, how many oil plants do we have in total, how many gas plants do we have, and so on. So I'm just grouping that. And I want to group that according to carrier. Then we want to sum it. Let's see what's coming out there first. Okay, now is everything summed according to the carriers. I just want to access pnom. Okay, what is pnom? If you attended the tutorial last time, you can just see here the generator. You can figure, like, first of all, read the stuff because it gives you some conceptual ideas. And then pnom is the nominal power. So it's the installed, the 2-day existing installed power plant infrastructure per carrier. And let's see how much we have here. Like I'm accessing now only pnom. We create maybe a nice plot. Well, like we maybe want a bar plot because we have super nice classes here, the carrier classes. And yeah, that's the kind of data we have now in Bangladesh for the existing infrastructure. Is someone from Bangladesh here? Like maybe we can hear something about data quality. Not sure if that is correct. Maybe we are missing out here.
Yeah, I'm from Bangladesh.
Yeah. Is this the data kind of?
May I know
okay,
what is the source of data currently you are using?
It's actually what we are using 3-4 different data sets that are merged together. One is so basically what you're using here is power plant matching. Like it was used it's also in the PyPSA community. It's matching different data sources. I would need to check like is Davide here as well? Oh, not sure.
Actually, just want to share with you another things. Few days back, I am also collecting some data of the power plants. But I do not get the energy efficiency or power plant efficiency data of all the power plant. I only get the data for few power plant. So then we are planning, maybe we take some average or doing something like that. So, but now I am surprising when you are showing all the data, all the efficiencies. So I'm just thinking from where you get all this data.
Yeah, it's really from 3-4 different data providers, and actually we can extend it. Like if you have another data interface for your country only, we can build that in as well, and then have the data as well.
Maybe later we can cross-check all these data, if you wish.
Yeah.
Okay, thanks.
Like I'm just checking, by the way. Yeah, like we use here. So efficiency is apparently not always tracked. You see that, right?
Yes.
So here, like what we are using instead is like, and Varun, like that's like, by the way, is it my Varun or is it no Hassan?
Yeah,
Hassan,
yeah.
right?
Yeah, Hassan.
Basically what we are doing is we associate a class of power plants. This is CCGT, combined cycle gas turbine. And we assign that in a later stage to a certain value. And let's check the data. We can use here mean efficiency. So this is the efficiency according to carrier.
But it is a sum. That is not mean.
Like now now I'm using a mean.
Sorry.
Because like it wouldn't. Yeah, like I changed it in between. We can also check the raw data, but at the end I want to show you that. Let's check the raw data. This is always the same value. Let's see here, oil 393, oil 393.
Okay.
You know, like somewhere in the code we assigned it to a certain efficiency.
Can I just say one point here? So the first thing which you showed, that the kind of distribution of the power plants, right? So composition, how many CCGT, how many coal, etc. The initial one, right?
Yeah, yeah.
Not this one. This is the efficiency you are showing, right? But
This
for
one.
that one, I think it is more or less representing the situation in Bangladesh, because given your this one, right? So what is the proportion? I'm just looking into what is the proportion of coal, what is the proportion of solar compared to others. This is more or less representing what the situation in Bangladesh is. And then I understand that efficiency, you have plugged in some of the efficiency numbers and you are assuming it's same for all those, but then they can be improved by taking into the exact efficiency numbers. So this is a kind of database you have with some assumptions, but that can be improved to represent the reality better, and so that we can see how the results change, right?
Exactly. And
yeah. Okay, that's
like
good to know.
100 points. Like if we have the, like what we just do this efficiency trick, we assign one class with one efficiency because we don't have the full data.
But I saw, but one thing
if we
sorry.
have the data, we can also
you can change it.
Exactly, depending on really what is in the region. Like we always need to cluster.
This is good to know. So this is really good to know that where you really want the local information to be plugged into, right? And the other thing which was a little surprising to me is that you were taking the efficiency value for solar much higher compared to the CCGT, which is really not the fact, because CCGTs are more efficient compared to the solar, even just by definition, right? So I was just a little surprised that, so they have very high efficiency value compared to the other power plants is a little bit, I don't know what I'm missing here.
Yeah, this is like a really good point. I mean, that's practically a way we describe renewables in PyPSA. I think there was a conceptual. Let me just find that quickly in the documentation. It should be here at the generator. No. Interesting. Like I think they had a nice plot here explaining that. Not sure what I'm missing out.
Also,
but yeah,
comment here.
Capacity utilization. So
sorry?
that means that I think it's capacity utilization rather than efficiency. That is the word which has been confusing over here. I think that means that if the solar is there, it will be utilized completely 100%. That is what that graph has been made. Like, but that's why there's one for wind and solar.
Not sure if I get it. But I mean, at the end, like I can just explain that like we have no primary input source. Like there's no like in CCGT there's fuel coming in, and let's say it has 1 megawatt input, megawatt thermal input. Then the efficiency is reducing that, and this is pure electricity, and basically it's there's no there's no change from one carrier to another carrier. It will be like direct, it's just producing directly the electricity. So that's how we...
So basically it's the generated output, how much that is being used, but then there is input coming in, but still okay.
I can show you I can show you also time series. Maybe that might be interesting. Fingers.
There will be peaks and all. Yeah.
Let's cross the fingers that there will be something. So, okay, maybe, you know, just to show that I'm not typing magic, I just got it from, I just did it a couple of times, but I'm now interested in
another question. Am I understanding that because you wrote it on the x-axis, the carrier, so because when for solar and wind, there is no carrier. So there is, so for, is that's why this is coming one, and for the others, because it's a carrier, so per carrier, what is the efficiency level? That's something which you are taking. I'm trying to understand.
Yeah, like we just we described the power plants by the carriers here at the moment. Yeah, it's really just because it's described in that way, and we just produce electricity. There's no conversion, you know, loss from one carrier from.
I mean, comment here also. I mean, this is normal practice for this kind of models because this is cost minimization problem, and wind and solar energy has zero cost, and it doesn't make any difference how to measure it, if it's 20% efficiency for solar or 40 for wind. It doesn't make any difference because we're just saying we will take some wind and solar energy, and it's a lot of it, right? So we're just capturing some of it. So that's it. So it's just matter how much is incoming to the wind or solar power plant, and do we want it to measure it in the same way as output or not? So, but it will not affect results in any ways because it's zero cost and it's abundant. So we just used a sum of it.
Okay. Yeah. I'll think a little more what it would mean for. Let me think a little more, because is this creating some kind of biased result for the renewables or not? That just needs to be looked into somewhere. I don't know. I mean, I just want to think a little more. Yeah.
Maybe just to let you know here that, like I'm plotting here the maximal available, like theoretical available solar generation in Bangladesh. I think that must be, I guess.
But actually, this availability still accounts for real working curves of PV panels, because we are calculating them when calculating cutout. Actually, cutout still contains data on technologies.
Yes. So exactly, like this is the solar profiles. So, okay, I think that was maybe the confusion. We have solar irradiation, you know, the sun gives us energy, is giving us sun rays. And then the photovoltaic power plant has obviously also a conversion and efficiency. That efficiency, let's say, is nowadays 20% or something like that. And we get here out a power profile. And if you actually map here also the irradiance profile, that would be, you know, probably 10 times higher or like 5 times higher than this. So there's a, as Katja mentioned, in the creation of this power profile here, there's already a conversion factor built in. So there's already an efficiency conversion happening from solar irradiation to power. And that's why here there's no further efficiency drop. Yeah? Because now we are already in electricity.
So Max, what is the unit in y-axis?
This is should be. That's a good question. That's a very good question. Let me check that. Let me check quickly the raw data here. So this must be megawatt. This is always megawatt. Ah, no, sorry. Okay, this is a bit confusing. This is a PU value, which means PU is always between 0 and 1. But I'm summing that here. Let's maybe I shouldn't do that like that. So I pick a single location now, okay? I pick a single location. Because like now it was summing up this PQ values, which doesn't make sense at all. So let's pick this solar power plant here. So this is a PU value, which means during that hour.
Is it availability factor? Is it availability factor?
Yes.
But
yeah.
Just a couple of minutes before you were showing the figure, the factor, it should be between 0 and 1. That time it was between 6, 5 or 6 value was, what is that?
Yes, because I was summing that up, you know, like if I have 10 power plants with PU values and all are between 1 and 0, and I sum them all up, then they can get both.
But does that make any sense? Because
no, like it doesn't make sense. Sorry, like that's why I have to show a single power plant, yeah. And like what I can do here is then, you know, multiplying that with the installed power. But I think I don't have any installed power yet. No. Sorry. Generating. No. Yeah, probably I don't have any installed power for solar. Oh no, I have some. Okay. I have some, so I could multiply that somehow. Yeah, like you can multiply that. Ah, okay, it was not working because I cannot multiply a plot. And I need to pick exactly the same power plant. So, you know, that's how that's the power output now, the theoretic power output that you could get at this location in megawatt with the given power plant that is installed there.
So this takes care of the kind of technology you have installed and its efficiency level, right? Yeah, because this is the output.
Yes.
Yes.
Yeah.
Okay. All right.
And you know, it takes into account, okay, here's bad weather.
Yeah, that I understand. Yeah.
Okay.
Sure.
Anyways, like maybe it looks now at the moment a little bit more complex than it is actually, because yeah, I mean that like this is really the pre-optimization stage as well. So this is really all the data we have, and then you can optimize that. But I think a colleague will show that us in a moment. I'm just wrapping up here and show you the way how I would export that to a CSV file. That might be again interesting for Oleg. So exporting, if I have here a documentation, I would look for some kind of data import export. And then it says here, export to CSV folder. So I'm clicking here, and then it's describing what do I need. So basically what I need is a CSV folder name, and that's it. Okay, so just using that function.
Max, is it export or I mean of the results or
Of
the
of
NC
the, all
files?
the of all the of the NC file.
Okay,
Yeah.
yeah.
So-
NC
so it's
files also readable. Yeah, I can.
So it takes the, like this was, you know, the command here.
Mhm.
And network is really that NC file that we imported here.
Right.
So it will only export, you know, this network. And let's give it a cool name. I was, I think Shanti. Does it mean, like, does someone speak Hindu? Can someone translate it? Is it Hindu?
Yeah, that's probably peace.
Yes, it's peace. Yeah, I wish you all that you have a lot of peace in your life. And yeah, let's see what's coming out here. Shanti, we have here a lot of peace, and here's all the generator CV. You know, that's exactly the same thing I opened in, like, from the object, and now you have also the data as a CSV if you want. Personally, I find it easier to modify that in the object as well, like here directly. You know, this is kind of modifications I can do easier, but like I can do it easier here in that format. But you can also, you know, change here your values, or add a new power plant or something like that.
Yeah, this is useful to know, because I
Yeah.
can see also that in the capital cost and those data, there are scope for improvement. So yeah, that's what I was just trying to see, what can be the local input. So that's really helpful. Yeah, these files are helpful. Yeah.
Yeah, perfect. And I think, Oleg, that's also where you could, you know, you can either build an interface to that CSVs, or you say you can build it to the NetCFD file directly. I would recommend you the NetCDF file, or at least,
Yeah.
like, yeah.
Yeah. I mean, not easier, just. I mean, omitting the step of CSV. Fine.
Okay. And this is the first part. And I think I just hand over to Katja now.
Thank you, Max.
So please explain us what you're gonna do now.
Oleg, it would be very helpful if you could please give me also rights to share a screen, because